Okay, so this is a figure showing a deep water wave, and this is a really good opportunity to show how basic wave motion works. Particles in waves, in deep water waves, don't move in a direction per se. Each one of the circles that you're looking at in this diagram is the path that water particles are taking. So the actual particles of water are actually moving, are actually orbiting in a circle, just have a diameter about a point. Whereas the energy in the wave is moving in a direction. So you can see at the bottom, you've got direction of travel, and that's talking about the energy of the wave, but you're not talking about actual wave particles. Much like when you take a garden hose and flip it to create a wave, you're moving energy in the direction that the flip is traveling, but the actual particles of the garden hose aren't moving anywhere except up and down. Very similar concept. So in a deep water wave, such as this one that we've got diagrammed, the depth is deep enough so that the water particle movement does not touch or come in contact with or be affected by the ocean floor. The particle motion dissipates down to zero before it comes in contact with or gets affected by the depth of the ocean floor. That effective depth, where there's no more particle motion due to the energy from the wave, is called the wave base. That depth, if it is half of the wavelength or more, then that depth is half of the wavelength. So if the wave is moving in water deeper than that, we call that a deep water wave. So you can imagine that a very, very small wave, a ripple, for example, could be a deep water wave if it was in very shallow water.